Topic 7-6 can be referenced with our Holtz textbook, Chapter 8, Section 2, page 525 through 532. I'm also referencing the mathisfun.com. There's a little bit more explanation on this if you need it under the Trigonometry Index, if you want to check that out too. Alright, for topic 7-6, we're looking at trigonometry ratios. You will need a calculator, so pause and get one if you need to. The main thing I need to make sure you understand is that we have to change our calculator when we're dealing with trig into degrees. So on your calculator, once you have it turned on, you're wanting to go to the mode button and then scroll down to where it says radian. Move over to highlight. It'll start flashing the degree button. So you want to change it from radian to degrees. When you're dealing with the sine, cosine, and tangent functions on our graphing calculator, this must be in degrees. Okay, so clear that. Now that we have it in the right mode, let's fill in some vocabulary. Trigonometry ratio is the ratio of the lengths of the sides of a right triangle related to the acute angles. So you will always be looking at a right triangle when dealing with this sine, cosine, and tangent. So filling in what each of these mean, we'll kind of get into it in a little bit more detail as we do the problems. But if you're looking at the sine of A, what that means is this angle measurement, I think I'll draw it with a highlighter. This angle measurement A opens up across from this leg A. So if you're looking for the sine of it, you're going to take the opposite side, which is an A, over the hypotenuse, which is always across from our right angle, which is C. So that's how they got the A over the C. The value of the side length of this side divided by the hypotenuse, which is this one. And we'll get into how to memorize this later. Cosine of A would be taking the adjacent side. When you think about something adjacent, you think of your angle, and the side length that shares that angle is the adjacent. So B is the adjacent side over C, the hypotenuse. For the tangent of A, you're looking at the opposite side A over the adjacent side B. Again, adjacent side is the one that shares the angle, and it's the leg that shares that angle it's looking for. So if we switch angles, I'll highlight this one in a different color, to angle B, that's this angle right here. The opposite of angle B now is B, this little b. The opposite would be like to draw your eye down across from where that angle opens up. And for sine, it's the opposite over the hypotenuse, which is C. The cosine of B, so this is our B, the adjacent side to it is the side length that shares the angle. It's this side length that shares that angle is the adjacent. So that would be A over the hypotenuse C. And then the tangent of B is taking the opposite side B over the adjacent side A. So I try to teach the students to memorize it with SOHCAHTOA. If you can remember, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So if we can remember these in a, sounds kind of Indian, a SOHCAHTOA. We'll get into understanding of each of these as we do some examples. Okay, let's look at example 1. You've got to find the sine of A, the cosine of A, the tangent of A, the sine of B, cosine of B, and tangent of B. Express these ratios as fractions. So let's again remember, if you need to, you can write that SOHCAHTOA on the top of your paper here, or actually I'm going to put it over here to the side. The sine is opposite over hypotenuse, sine of any angle. Cosine is adjacent, I'm going to use a big A, adjacent over hypotenuse. And the tangent is taking the value of the opposite over the adjacent. Alright, keeping that in mind, we're looking for the sine of A. If you remember that sine of A means this angle measurement right here, I guess it'll help to highlight it again. The sine of A, if you look at the lines, the opposite, it's a 5, opposite over the hypotenuse, which is 13. So the sine of A is 5 over 13. The cosine of A would be 12 over 13. We're taking the adjacent over the hypotenuse. And the tangent of A is taking the opposite over the adjacent, 12. Again, make sure your eyes follow all the way opposite. Opposite is this line right here to this angle. Alright, so if you need the sine of B, the cosine of B, and the tangent of B. The sine is opposite over adjacent. Opposite B. Highlight that one in pink. This angle, you're looking opposite that. What that opens up to be is the 12. Opposite over hypotenuse is 12 over 13. Opposite over, adjacent. Adjacent to it is a 5. Adjacent over the hypotenuse is still a 13. And then opposite over adjacent would be 12/5. Opposite is the 12, adjacent is the 5. So these would be your answers for the sines and cosines of both and tangents of those two angle measurements. So if you get the idea, you're doing the same thing with these sines, cosines of S and sines, cosines, tangents of E. So again, you would be looking at each one of these. The sine of S, cosine of S, and tangent of S. Sine of E, cosine of E, and tangent of E. Take a few minutes and fill these in. Maybe pause it. I'm going to just go ahead and fill them in, and you can check what you got to be true. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is your opposite over adjacent. Opposite over hypotenuse. Adjacent over hypotenuse. And opposite over adjacent. So check to see that you got both of those too. You can use trigonometry tables to evaluate expressions involving the trigonometric ratios. Finding the value using the trig table. Well, we can either use a trig table attached, or we've got a graphing calculator. So we're going to use our calculator. Make sure that you have it in degree mode. Make sure you put it in degree mode. Just as a reminder, I'm going to write that. Okay, so if you're looking for the cosine, you would hit cosine first. Make sure I made that over here. The cosine of 41, close parenthesis, is approximately, you can use equal to, but you could probably make it a squiggly lines like this, because it's really approximation. Carry it on out 4 places would be 7547. The sine, you get the word sine, 78, is approximately decimal point 9781. But you could do either one. I do have a table attached to this. Okay, let's walk through 4 more examples. This one they're asking to find x in all of these and also the equation. So if we were going to write the equation, that's setting up what they're asking. So if you're looking to solve for x, then you know the hypotenuse, so you can use sine or cosine, because hypotenuse formula is for both of those. Remember SOHCAHTOA. SOHCAHTOA. Sine, cosine, and tangent. If this helps to write it again, SOHCAHTOA. Alright, so since we know the hypotenuse, the one across from our right angle, is 9, then we're looking, let's try sine. The sine of 21 is equal to something unknown, which is what we don't know, the x, over the 9. Alright, there's 2 ways of looking at this. If you already know a value and you're looking for something times this would give me that value. Just an example, if this was 12 and this was 2, 12 times 2, I know my x was 24. So you're actually multiplying the sine of 21 times 9 to get x. So when your value unknown is on top, you multiply. Let me write that. Multiply. After doing a couple examples, you'll get that. So there's the equation. I've already written it. So to solve for it, you're just going to multiply the sine of 21 times 9. Oops, I think I put too many parentheses. There's already a parenthesis here. Sorry. Sine 21 times 9. Okay, again, this is an approximation. Carry it out 4 places. 3, 2, 2, 5, 3. 2, 2, 2, 5, 3. Okay, for this one, you also know the hypotenuse, so we can use sine again. Let's put the equation down on this line. The sine of 53 is equal to, again, if we're looking at that one, the opposite we don't know over the hypotenuse that we do know. What do we know to do? Multiply. So we've got the sine of 53 times 13. Approximately 10.3822. As long as you carry it out at least 2 places, I think that should be okay. Alright, again, we still know the hypotenuse. Opposite over hypotenuse. So again, let's use the sine. Each of these examples, we keep using the same trig function. The sine of 36 is equal to x over 8. So the sine of 36 times 8 is 4.7023. The equation for y, since we know this is the adjacent to it, let's use cosine, because cosine is adjacent over hypotenuse. So we're going to use the cosine of 36 is equal to what we don't know over the adjacent, over the hypotenuse we do know. The adjacent over hypotenuse. One's opposite over hypotenuse, the other is adjacent. So this time you're looking at sine of 36 times 8. Approximately 4.70. Alright, how do I get the same thing? Oops. Since we don't know y over 8. Oh, I'm sorry, I did sine again. This is cosine. I was in that mode. Cosine of 36 times 8. I knew it wouldn't have been the same thing. So this is 6.472. We'll just stop it there. Alright, so if you're solving for x, the equation is sine over 50 is equal to what we don't know over 11. So again, you're going to multiply the sine this time. Sine of 50 times 11. Make sure you put a parenthesis, otherwise it'll do the sine of 5,011, and it'll end up being wrong. 8.426. The cosine of the same thing, since this time we're looking for y, and y is the adjacent to this, so it's the y over the 11. So cosine of 50, close the parentheses, times 11 is approximately 7.07. We'll carry it out a little bit more, 06. And again, carrying it out at least 4 places will suffice. And that is the example for Unit 7-6.